Okay, thank you very much. Good morning, good afternoon. I don't know where you are from, but I'm glad to meet you for this lesson concerning energy used by transport systems and consequent local and global emissions. And we will see these emissions and these energy consumptions in different transport modes in order to understand which can be the future engines and motors and the role of electric motors. There will be another seminar in the next month concerning specifically electric motors, but now we put the basis for the second lesson concerning this subject. I'm Bruno Dalla Chiara. I'm professor in Politecnico di Torino of Transport Systems. I teach typically to civil engineers, students in the master degree in civil engineering and mechanical engineering, with some lessons also in automotive engineering. Okay, let's start with the outline of this seminar. First of all, I would like to outline how much the transport systems impact the energy usage. Second, how energy consumption has evolved, so how we have arrived to the present situation. Third, how much the use of energy impacts the different transport modes. That means inside each transport mode, what is the impact of energy consumption. Fourth, that is a bit less technical, but much related to our future possible solution, that is the involvement of governments in the use of oil for traction, oil-derived fuels. And the fifth point is what solution can be perspective in a changing economy concerning electrification or whatsoever. We will see that. So let's start with this. If you take any book of the last decades of the last century and you search in the first pages what is a transport system, you will find that a transport system is typically based on three elements: the traveler, the infrastructure, and the vehicle. But if you look at literature and researches more recently, you will find that a lot of publications deal with energy, because while in the last decades energy was considered a part of the transport system, not so relevant, nowadays it has become important, because as we will see shortly, we rely mainly on one energy source, that is oil, crude oil, and with oil-derived fuels. So when we put in question the use of these sources, then this becomes relevant in the transport system as a whole. If you look at literature, you will find that there are a lot of publications concerning efficient public transport, intelligent transport system, well-used vehicles, new solutions, electrification, engines, new powertrain, and decarbonization. So this means that there is an increase of attention on this subject, and we are exactly in the years when this has to be considered in a deep way in order to find a path for the future transport systems. So I start with a few pictures concerning our cities in Europe, at least, a bit more than 1 century ago. You can recognize London, Milan, and Paris. Okay, you can see that people were walking, were using horse carriages. There were some tramways. Some of them were already electrified. Some others were pulled by horses. Then 1 century ago, what has happened? That if the goal 1 century ago was to guarantee a diffused motorization, to avoid the use of horses, which left something on the roads, and these provoked diseases and stink, and to allow people to travel for longer distances and bring also materials, freight for certain distances, then diffuse motorization was probably a goal of 1 century ago. And this goal has been reached. As you can see on the right side, in the case of Paris, in the bottom part of the picture, you can see exactly the same street. So horses and people walking and horse carriages have left the place to cars, buses, tramways, and unfortunately the situation is not always like in the second picture with all that traffic, but what we have reached is a diffuse motorization. And with that, since we have chosen one source, as I said before, that is crude oil, though the first car was actually the first car was was electric, and there were already some experiences with hydrogen. But the choice was to have a liquid fuel to be dropped in, reversed in a tank, and it was much easier for everybody to move that way. There were some, let's say, question marks concerning the use of aldehyde fuels, but we will speak about that later. Anyway, this has taken place in a regulated way, controlled, and we have arrived to that point. So this is a picture of the city I live in, that is Turin, exactly the same square. You can see on the left side some tramways, horse carriages, and people walking again. On the right side, again, traffic lights, tramways, electrification, motor vehicles, buses, and light-duty vehicles. And there are also intelligent transport systems on the right side, but you cannot see them. So this has brought to the concept of sustainability, that is a core of our network, sustainable systems, sustainable transport systems. And this has taken place in particular at the beginning of 90s, when the conditioning factors concerning the pictures that we have seen before started being important. And they are the saturation of the land, because no more available space was could be used, for new infrastructures, or at least was more difficult. Second, the source, the energy resource that we have chosen 1 century ago, more or less, that is crude oil, became as felt as limited, or anyway, available, but not at the same economical conditions. Third, a sensibility towards the environment at local level and global level, which was not so felt before that period. Then the possibility to maintain all those infrastructures in terms of operation, both the infrastructures and the vehicles, and updating them from the technological point of view. Then safety. In those pictures, the dead people on roads was not a main problem of the society. There were much more diseases and the like. But nowadays, the accidents on roads have become a main cause of death in our world in many countries. And last but not least, something related to the increase of mobility. So a mobility rate which could, let's say, not favor the relationship on a daily basis that, or even working on a daily basis for many people. All these has brought to the context of sustainability in the transport domain. Sustainability, as you probably know, is constituted by 3 main elements: environmental, economical, and social, which, if you apply the concept to the transport domain, you can recognize that those words that I mentioned before, space, air, energy, can be coupled with environmental aspects of sustainability, then production, operation, maintainability, and updating of infrastructures mainly can be coupled with the economical element of sustainability, and safety together with security and the intensity of mobility can be coupled with the social aspect of sustainability. So this can bring to a definition that is sustainable mobility. I would say goods to be transported, and I would not like to use mobility of goods, but mobility means therefore responsible, implicitly, movement of people and goods that balance efficiency and environmental stewardship and socially equitable cost. So these variables that I mentioned before can be measured: space, energy, environmental at local and global level, then the economical aspects, cost for the operation, for the maintenance and so on, safety, and movements per unit of time. Now we concentrate on energy and environment. That is the goal of the seminar today. First of all, how much the transport system impact the use of energy? Well, if you were in front of me, I would ask you, according to your knowledge or your, let's say, sensibility, what is the impact of transport system on the whole production of energy and consumption too in Europe? Well, it's nearly 1/3. That means that given 100, the production and the consumption is following because we do not store much energy or we use it immediately after the production, then 1/3. That means that transport systems are much relevant in terms of energy consumption. And in the world, this value is a bit lower than in Europe because many people walk, use still horses in some parts of the world, and this reduces the value that a few years ago was 1/5. So 20% of the energy produced in the world was used for transport. But in the recent years, this value has been continuously increasing, and it arrives to nearly 1/4 and even more. 1/4, sorry. What about crude oil? That is the energy source that we have chosen for cars, for planes, for ships, for motorbikes, for buses, for trains where you do not have an electrified lines. So for all these transport modes, we have chosen all the right fuel. And nowadays we have reached nearly more than a half, sometimes even 65, 66% of the global oil consumption is associated to transport systems. So this means that there is not only a nearly monopoly condition in terms of usage, but also the users of monopoly, the users in this monopoly of crude oil are just a few. We call it also monopsony. That means that there is one user for the producer. We are nearly in that condition, not one, but transport systems are the main user of oil-derived fuel. So this means that in the decarbonization context, transport systems are those that are immediately hit by this evolution. In this context, we may split a bit in terms of final oil consumption in the world. What are the components in this consumption? Well, you can see that aviation has more or less 8.3%, navigation 6.8%, rail a very little part because rail systems are typically electrified and the specific energy consumption in the rail domain is lower, much lower than in the road one, and road has nearly half of this energy consumption. Of course, this value, 65.2%, varies in the years, but more or less, as I said before, it's between 50, 55, and 68, something like that. Okay, what about the variation in the years and the incidence of transport systems in terms of total energy consumption in each European country? As you can see here, in different years, this incidence, this percentage of consumption by transport system in the whole energy consumption has not varied a lot in 10, 15 years. I take, for example, my country, Italy. You can see 31.7%, but in the values in the years are more or less the same. You can distinguish Luxembourg, that is nearly 60%, because in Luxembourg you have a little country with a very good road network, with a low incidence of industry and a high level of traffic. So this means that you have this percentage. The opposite value is that of Finland, so a quite opposite condition. Many countries are more or less around the average value, as you can see, 28, 30, 32, 34%. That is incidence of transport system in the whole energy consumption. What about the CO2 emissions? So we start saying, what are the emissions? Well, the emissions are a bit lower in terms of percentage. That is more than 1/4. Some years ago, they were 1/4, and now they are increasing. Why is there this difference between 33, more or less, and 1/4 or a bit more? Well, This can be given, can be justified, you can give reasons for this difference with different thoughts and variables. But there is one main that you can distinguish. In the transport system, you have some of these that are typically rail systems and metro systems, undergrounds, people movers that typically rely on the electric grid and typically can transport, especially railways, high masses. So this means that considering the fact that specific rolling resistance of rolling stock on railways is much lower than that on road, of course, if you transport goods and freight, so they don't travel empty, then the impact in terms of flows is relevant, but in terms of energy consumption and most of all of CO2 emission is much lower because they can rely on the electric grid. Given that, we can see how much I said a nearly monopoly condition before. Well, we can distinguish that both in Europe and, as an example, United States, the impact of crude oil on the energy consumption that is made in these areas of the world is more than 90%. It was something like 96% in 2011, and nowadays we are around 91, 92%, given some activities that I will tell you later. All the other sectors in the world, I mean, industries, agriculture, services, buildings, can rely typically on the electric grid. Transport system being mobile, by definition, do not, because they have to bring typically with them, I mean, vehicles, some liquid fuels, at least this has been done so far, that they can burn on board in order to allow for mobility. Given that, as I said before, railway system, undergrounds, cableways, automatic people movers are those systems that can rely on the electric grid, so they can be independent from crude oil. Okay, then we can also split what is the role in terms of CO2 emissions of the single transport modes. And this graph outlines the impact of freight vehicles 6%, light vehicles 6%, shipping 2%, transport aviation 2%. But notwithstanding the fact that there are different sources, and a few years have passed, 3 years from this data, if you look at other sources and the most recent years of 2024, of last year, then we can see also some impacts, some, let's say, researches that mention an impact of transport system on the whole production of CO2 from human beings, that is even 1/4 or 26 or even a bit more percent in terms of CO2. What does this mean? This means that in the world, the impact of transport systems in terms of CO2 emissions is increasing. In Europe, it's nearly constant with some oscillations, but in the world, it's increasing because motorization is taking place in areas of the world, like in China, like in India, where the population is much higher than that of Europe. And from the combustion of aldehyde fuel, we have a certain quantity of CO2 emissions. What about the position of European Union? Well, some years ago, starting from 2014, then in a more relevant way in 2019, and in 2021, European Union stated that it had two main goals: reduction of CO2, increase of renewables, and increase of energy efficiency. In 2022, stated that wanted to fit for 55. That means to reduce with respect to 1990 levels the impact of CO2 from human beings, and wanted by 2021 to reduce it by 55%. So how can we obtain these goals? modal shift, because we can easily understand that rail systems, metro systems, people mover reduce their impact in terms of energy consumption and consequently emissions, but they can rely on the electric grid, and this is the main role, the main reason. Then second, we can invest, we can let powertrains migrate from the present one to new greener ones, and also use intelligent transport systems. And third, to use applied maths for optimizing the use of our vehicles, in particular when dealing with freight. Okay, what about greenhouse gases? Because I spoke about CO2, this is one main source of, let's say, component of greenhouse gases, but also if you release natural gas in the atmosphere, this increases greenhouse gases, and in particular, the impact is 20-25 times higher than that of CO2, given the same quantity of gas. Then also nitrous oxide is a component which contributes to the increase of greenhouse gases emission. According to some literature, also the space debris that is surrounding our world with more than 1 million little pieces can contribute to. I don't know, it's not my subject, but I tell you for being more complete. Okay, so we know from literature, we know from our daily experience, we know from our knowledge that we are looking towards decarbonization. Consider that decarbonization means to reduce or to avoid the use of carbon, but we have to keep care about one thing in the transport domain, that is, there is no liquid fuel at normal temperature in the world which does not contain carbon. So decarbonization in absolute terms is not possible, at least if we want to continue to use a liquid fuel, unless we move towards some alternatives that we will see later. Okay, so what can be the path, the instruments for reaching or at least pursuing decarbonization? Well, one is defossilization. That means if we let plants grow, and these plants can be a combustible, a fuel for our engines, then this means that during their growth, they absorb CO2 from the atmosphere, and then by burning them, I mean the fuel that is obtained through them, you will create some emissions of CO2, but this could be neutral at the end. And this is called defossilization. Sorry if I've simplified the subject in a very basic level. Then low carbon and renewable hydrogen. Hydrogen, as you know, is abundant in nature, but you find it in the water, in natural gas. You have to separate H from H2O or CH4, and so this implies a lot of energy. And if this energy that you use is renewable, then you can speak about a low carbon and renewable hydrogen. Ammonia, you can produce ammonia and you can burn it, and this is another possibility. Energy storage in electric batteries, and this is the solution connected to electrification in terms of full electrification, but because we can also speak about a gradual and partial electrification. Then there are the biofuels, biomethane, biomethanol, and bioethanol, and synthetic methane. All the synthetic alternatives are also called e-fuels. We have not to neglect the so-called CCUS, that means to capture, to use, utilization, and to store CO2. But for the time being, this process is very expensive, though is a possibility for the future. Let's not forget that to reduce CO2, the main way is to grow plants. So we try to make a lot of efforts in the transport domain and in the energy domains, but we can grow plants. So what is, the first question was how much the transport systems impact on the energy usage, and we have understood nearly 1/3 in Europe, and it was 1/5 in the world, becoming 1/4. And in terms of CO2 emission, the values are a bit lower thanks to railway systems mainly. The second question is, how energy consumption has evolved. So how we have arrived to this situation. We can see at first the incidence of single transport modes, then the circulating road vehicles and the fuel consumption. Well, as regards the consumption, this is an objective value. This graph is old, but I will provide you shortly some more recent data. And it's just the sum of all consumptions by different transport modes, by cars, by buses, by airplanes, ships, and so on. So you sum them up and you obtain these values. And nearly 20 years ago, the incidence of road on all 33% of energy consumption, that becomes 100 now, was 82.5. So road transport has a much relevant role. Then there is air transport, and then railway, which has a much lower impact and is 2.6. It was 2.6, and then inland navigation. Some years later, bit less than 10 years later, but the values in blue, in light blue, are of the period just before the COVID, then these values didn't change much. So road transport remained the most relevant one, and rail transport had some variation, and air and inland navigation more or less the same values. If you refer just to domestic aviation and domestic navigation, the impact of road transport reaches the 94.5% in Europe. So this means that it's absolutely relevant. So if we want to decarbonize transport system, of course, we have to look in particular to road transport, and we have to keep care about the fact that rail transport is not impacting so much in terms of energy consumption because it relies on, let's say, a more efficient transport mode. This comes from the fact that the contact of the wheel on the rail is rigid and is nearly a point, while in the road, this is an area which has pros and cons. The fact of being an area increases consumption, but it also helps the adhesion. So you can win higher grades, you can accelerate and decelerate in shorter spaces, and this can be not done in railway. You have to guarantee long spaces. Then more recent data show more or less the same values. So what I wanted to show is that in the years, these values are more or less conservative with a quite relevant role of road transport. And we have arrived to this situation looking at the curve which represents the circulating vehicles. This graph is referred to Italy. Shortly, I will show one concerning Germany, but they are all similar in Europe. They are like S-curves. For those who studied economy, the S-curve is typically of a product with the concept creation, the concept development, the market development, then the business optimization, and then what do? How many of you have the horse carriage at home? I suppose nobody, but it had an S-curve quite longer in the centuries, and then it dropped down when the car was invented. Now we have to think about what will be the future. We will discuss this in next seminar with me. But what I'm telling you now that by registering, so each car which has been registered in the decades has implied an increase of consumption that has brought nowadays to what we have seen before. And nowadays, more or less, we have saturated the market because for each person able to drive, at least in Europe, you have one car, though not necessarily of property. Okay, so we have saturated the market. This can be shown by this graph. This is referred to the registrations in Italy, and you can see that starting from 1995 until nowadays, these registrations oscillate, while before that date, they were continuously increasing. And this is the crisis of motor cars, because the production was no more from the beginning of this century that we were accustomed before. So it's a substitution instead of a saturation of the market. This graph is referred to Germany, and you can see similar trends. So an increase from 50s, 60s until the beginning of this century, and then a flat trend. What about the world? As a matter of fact, the situation in Europe, so as in the United States and Japan, with a, let's say, conservative value in the recent year, is not the same in the world. In the world, we have a continuous increase of motorized vehicles, and China, which started motorization in the 80s, 90s, and mainly in this century, in 2008 had already one-fifth of the vehicles circulating in the world. So the saturation that we have reached in Europe is far away to be completed in countries like China, in India, and this contributes to the global consumption because of the percentages that we have seen before, and to the global emissions. Okay, then given this, what about the number of vehicles in the world? Because we have seen that, for example, in Italy, we had 40 million 40 million people able to drive. So we take 60 million, that is the number of inhabitants in Italy. You reduce it by the underaged and you find the number of people able to drive, also old people not able anymore to drive. And this number as a correspondence with the vehicles that are circulating. The same is more or less in all European countries, but in the world it's not like that. In the world we are nearly 8 billions, and the number of circulating vehicles nowadays is nearly 1.3. So the motorization index in the world is much lower. But if we continue to increase motorization, then we have to be worried about the energy consumption and the emissions. So this is the number in 2015, 1.2. Now we are around 1.3 billion vehicles in the world. If we take just as an example India, you can see that there was an increase already in 2000 that has brought to an increase of motorization and traffic there. What about energy consumption? While we have seen a continuous increase of circulating vehicle and then constant value more or less in the recent years, as regard or increasing in a smooth way. As regards the energy consumption, it's reducing because of some main reasons. New engines, more efficiency, a different mobility, which uses also other transport modes in the past, more than in the past. For example, high-speed lines were not present 20 years ago, 30 years ago, or depends on the country. And this increase of rail mobility has contained the usage of fuels in road transport. And then fuel and road pricing, which has an incidence, and intelligent transport system. If for going from A to B, I have the minimum path and I avoid traffic because I'm informed about that, then this contains the use of emissions. Sorry, I make little examples just to let me understood. Then as regards the present and the future, the forecasts are agree typically on a reduction of fuels for road transport because of the reasons that I said before. I simplify them. But if we look at motorization index in the world, as I said before, while we had, for example, in 2015, United States with 800 cars for each 1,000 inhabitants, that means that more than one car for each inhabitant, and Italy, for example, or Greece or Finland or Norway, France and Germany were around 5 and 6 vehicles for each 10 inhabitants, then China and India were quite at lower levels. So the motorization index is quite lower. Some years afterwards, these values have changed a bit with countries which changed their position in the world. There are also different sources, but more or less the situation is like that. And still, we don't have China and India in these countries, which have a motorization index that is still low. So if we look at how mobility has taken place in the recent years, these are data which regard the million passengers per kilometer traveled by road. What you can see that around 2004, 2005, there has been a reduction in the increase of daily mobility, so in the whole traffic of passengers by car, and mainly passengers. Well, I don't enter into detail, but what we can see is that in those periods we had some modifications in our society. The use of internet, and in many countries of Europe, because these countries are from Europe, the increase of high-speed rail. So a change of mode, and there is also a reduction in natality. So in the population is nearly conservative. So of course, if you don't increase population, you don't increase flows neither. Okay, so what about absolute numbers in terms of fuel consumption? Then we will arrive to alternatives. Again, I use an example to let you understand what I would like to pass as concept, but we can make a lot of examples if we want. In 2005, in Italy, for example, we had 29 plus 18 billion liters of petrol and gas oil consumed for road transport. So this makes nearly 48, 49 billions. In 2008, according to what I said before, this value was reducing. So something like 24 plus 7, 31 billion liters. And consider that gas oil is much more used, diesel is much more used than petrol because heavy-duty vehicles, which travel a lot for long distances, use mainly gas oil, and within motor vehicles for private uses, typically those people in the past, at least, who used more the motor vehicles used diesel cars. And so this brought to a much higher consumption of diesel with respect to petrol. What about China and India? So if we look at, for example, these 31 billion, and this is expressed in liters. To obtain tons, so you have to multiply by 0.7 or 0.8, that is the density of an oil-derived fuel, and you obtain something like 25, 26, 28. So a value that is near here. So a country like Italy in 1 century, a bit less, has reached this amount of liters consumed in a year by motor vehicles for road transport, while in these years, China and India have reached quite higher values with a low motorization index. So this means that with a population in China and India that is nearly 3 billion inhabitants and a population in Europe that is 500 million, with a motorization index that I said before, and if you look at energy consumption and consequent emission, then I think some worries can be arisen. I'm not saying China, India, or any. I'm just saying that in the world perspective, the increase of mobility with internal combustion engines and with those data that I mentioned before can become worrying, especially if we think that oil-derived fuels cannot be so available in the future at popular prices as they've been so far. What about the incidence of heavy-duty vehicles? Well, this is just an analysis. They oscillate between 30 and 40%. So given that 100 of road transport in terms of energy consumption, that of heavy-duty vehicles is around 30, 40%. And if we look at this vehicle for freight transport, the main, as I said before, the main fuel is that of oil-derived fuels, petrol. Then, if you look at railways, I take always as an example one country so that you can make a comparison. Railway transport had in the last 10, 15 years an impact in terms of tons of oil equivalent a bit more than 1 million 3, 1 million, 1 million point 3, 1 million point 8. And this can be distinguished in this graph, with also some a bit more recent data. But what you can appreciate is that the impact in terms of energy usage of rail transport is much lower than that of road. So how much the use of energy impacts the different transport modes? Because we have understood the impact of transport as a whole, we have understood the evolution. Now we have to see inside each transport mode what is the impact of the energy usage. Well, it varies a lot. What I can tell you is that in road transport, we have vehicles of two wheels, then 2 axles, 3 axles, 4 axles, 5 axles, up to 12 axles, more or less. So this varies a lot also in terms of energy consumption, the mass, and number of variables. And in rail transport, it's more homogeneous. In air transport, we will see shortly, so as in maritime transport. So if we want to consider an homogeneous area of road transport, we can refer to freight transport. So transport of goods typically by heavy duty vehicles. If you look at literature and in different publications, you can find that the impact of energy consumption within road haulage is more or less between 24 and 28 and 38. So this means that if you have a variation in the cost of crude oil, this is much felt by road hauliers. If you look at railways, this does not happen because you have a variation between 4 and 6%. 6 is referred to the fact that you have frequent acceleration and deceleration phases and many stops, like for example, in a metro system, in an underground. While if you look at national railways, typically you will find in the national budget of this railway 4 or 5% more or less. This is the incidence of energy on the whole production of the service. Yes, of course, we are referring to economical terms, but if you take the ratio between the specific rolling resistance of road transport and rail transport, you will find more or less the same ratios. That is 1 to 5, 1 to 7. So this means that road transport has nearly 7 times higher energy consumption than rail transport. And you can find it also this in these values. Notwithstanding the low incidence of energy in rail transport, there is a number of activities that you can see here in red: energy recovery, then optimization of speed, materials, and so on, which can contribute to the reduction of energy consumption in the rail field. In air transport, some years ago, we had something like 14, 20, 25, 32 oscillating, but in recent years, we are around 35, 33, 40%, and this is the incidence, so as in heavy-duty vehicles, of energy consumption in the whole cost of operation of air transport. But what I want to underline, that is written here at the bottom of the slide, is that air transport is the sole transport mode where you don't have immediate alternatives or short-term alternatives to all the right fuels. Here you can see the price of jet fuel and airlines fuels cost as a percentage of total operating cost. That has some similar values with respect to those that I showed before. Okay, maritime transport. Maybe you know that, well, we don't travel anymore by ships, except for amusement, not for passing from Europe to United States or going towards East Asia. While maritime transport is much used for the transport of goods in the world. Nearly 90% of goods traveling around the world use maritime transport. So this means that it has an impact, which apparently is not so high because we are around 3% of the consumption in the world, and also emissions have similar values. But these ships, which have enlarged in the decades, bring a lot of containers, for example, if they are container ships, on our coasts, and they transform these containers into road transport and road traffic and rail transport. Or rail traffic. And we have passed from Panamax ships of a few thousand TEUs to 24, even 26,000 TEUs. And this has reduced the energy consumption per unit. So this is not so felt as a relevant problem in maritime transport. Notwithstanding that, also maritime transport is moving towards decarbonization and reduction of pollutants through low sulfur fuel oil. Then if you use internal combustion engine, you have to insert the scrubber for completing the combustion, liquefied natural gas, hybrid internal combustion engine, like in road transport nowadays, methanol, hydrogen, and ammonia. So there are efforts in maritime transport to contain as well the carbon and the emissions at the local level. Fourth point, what is the involvement of the governments in the use of oil for traction? Well, in the last century, we have seen a benefit for everybody, I would say, for the vehicles or for the industry that had to produce these vehicles, for the infrastructures, because civil engineering had to build new infrastructure and to satisfy the increase of motorized mobility, and for the state budget, because from fuels, the budget of the state is increased in terms of excises that are obtained from the fuel combustion. Some constraints that we have seen before when defining sustainability have been introduced in the 90s, and more or less, I refer again to Italy here, but I have a slide shortly referring to Europe, more or less the incidence of excises on taxation on a liter, or on the cost of a liter of petrol or diesel is around 48, 50, 55, nearly 60%. So this means that when vehicles circulate, a great amount of money arrives to the state budget. So if we decide to electrify, we have to consider all these considerations, but we have to think also about one thing. What are the natural resources that typically a transport system uses? Energy, air, and seen just before in this air. We don't pay for the use of the air, but we use air in terms of oxygen for combustion, and we emit something at local level or at global level, so CO2. And space. Do we pay for the use of space by road transport or by any transport mean? In the rail transport, yes, because trains pay according to the distance. But in road transport, we don't pay according to the distance, except in some cases. For example, in German motorways, in Italian motorways, in French motorways, in some, or in Spanish too. I'm not sure, but anyway, according to the distance you pay. But if you use the normal network, you don't pay according to the distance. And this concept is called road pricing. So you pay according to the usage that you make of this infrastructure. So if we look at electrification, we have to consider the state budget, we have to consider the alternative energies, we have to consider the emissions, and we have to consider the fact that for the budget of the state, some alternatives should be found. So we arrived at the last point. We have seen in many European countries an evolution of infrastructures like this picture shows. So in the 70s, 80s, and 90s. And China and India are in the growth of these infrastructures. But the new goals for us, for Europe at least, efficiency, quality, safety, and security, are those that typically we find in literature. We are not looking anymore to diffuse motorization because we have reached that goal. So we have two main alternatives, either to move on high-speed railways with motor cars, buses, public transport, metros, and we have listened to the lesson before by Professor Francesca Robusta. And as an alternative, we can use much more public transport, and this means to plan and to intervene on the territory. And this has to be done, in my point of view, in countries where the motorization level is still low and it's increasing much. But more fixed installation means less emission, and this is clear. And this means a role of the state in this context. Then more private vehicles means more emissions unless we deal with new engines, new hybrid vehicles, and electric vehicles as far as they can satisfy the demand. And what about the position of Europe in this context? Europe has said, let's reduce the CO2 emissions by vehicles at the production level. In 2015, it was 130 grams for CO2 per kilometer. In 2020, it was 95 reduced. But afterwards, then the other number is referred to light-duty vehicles. But this has been done also in other parts of the world, as you can see in this graph, because Mexico, Brazil, India, Canada, United States, China, Japan, South Korea are looking at this reduction of CO2 at the production level. Europe is in the value 95, you can see it there. And this value has been changed in 2023 by European Parliament to 0. But this has to be completed because this 0 is calculated at the vehicle level. But if we look at CO2, we know that we need to calculate in the whole energy process, as we will see shortly. This is referred to the conventional driving cycle that is called WLTP. But we will recall this aspect afterwards. If we analyze the emissions of CO2 just at the local level of the vehicle, then we consider CO2 problem as someone else's problem because the CO2 will be emitted elsewhere. So what is the solution? First, we have to calculate the emissions at local level and the global level. Of course, we have to pass through the vehicle, and to do that, there are methodology. I just take a very rapid look at this. There are these procedures which refer to the WLTP, so conventional driving cycle, which allow you to calculate or estimate the local emissions, but also on the conventional cycle to estimate the CO2 emissions at vehicle level. Okay, these emissions derive from the consumption of oil-derived fuels, which, according to the kind of engine you're dealing with, you have a map considering the engine and the fuel. This map, as you can see here, has a high efficiency when the vehicle is moving smoothly, for example, in a motorway, but has a low efficiency, 16, 18, 20%, when the vehicle is moving in a city. And at the same time, we now introduce the electric motor that is on the left side, 94%, 88%, a variation of efficiency that is much higher, a value much higher than that of internal combustion engines. So, since Europe wants to look at both global emissions, CO2, and the local emissions with this directive 50 of 2008 that has been substituted. These are the values that have been substituted by the Directive 2881 of 2024, November of last year. This means that the European Union is looking both at global emissions and at local ones, with a new table, that is this one that was mentioned also by, at least in the value of nitrogen dioxide by Professor Francesco Robuste last seminar. Well, since we want to reduce local emissions, then we have to find a solution. We will see this solution in my next seminar, but what I can say you now is that either we go all electric, but we need to keep motorways probably with road by charge while driving possibilities. We need to provide recharging possibilities, and this implies certain calculations in order to avoid queues on our roads. Then we need to verify if the distances are compliant with the possibilities to recharge the vehicles, especially in an urban context. And so we open the door to a number of alternatives, at least some alternatives. So we were used to use to consume crude oil. We are used so far to consume crude oil, but now we have also, though it has been used in the recent years or in the recent decades, natural gas, not coal, of course, but we could use fuels from synthesis, biofuels, hydrogen, liquefied natural gas, and we could recharge also batteries with power production plants. These are the alternatives. We will enter into more detail in the next seminar, but what we can say is that we start thinking about a split of local travels, frequent, short, and less frequent long travels. The first ones could be associated to electric traction without any problem. The more extended ones with internal combustion engines. And the most flexible solution is a plug-in hybrid, but it's possible that a full electric vehicle could be compliant with the needs of a person, while an internal combustion engine, provided it doesn't emit much, but we will see that next time, doesn't emit much. This is a slide that I will recall in next seminar concerning the alternatives that we have in hybridization and full electric vehicles and fuel cells. And what we need to say, and I will shortly conclude, we need to analyze all the energy chain well to will. And we need to do that in the life cycle, because if I produce a vehicle in China with an incidence of coal of the 63%, I produce the CO2 there, notwithstanding the fact that apparently the electric vehicle is not emitting here. So what I need to analyze is to complete the decision of the European Parliament by using the well-to-will and the life cycle. Well, I skipped this slide because I will use it next time. And I just show you this graph, which represents the alternatives that we have nowadays in front, but we will enter into more detail in the next seminar, according to the actual usage of the vehicle. So there is not a single solution. There is a number of few alternatives that we have to analyze in the well-to-will and in the life cycle to understand which are the most promising one in terms of energy and emissions. Okay, so our future cities probably will have more metros, more intelligent transport system, more oil-independent vehicles with interconnected possibilities through intelligent transport systems. And I arrive to the conclusions, we rely on a TEN-T network that is by rail, and this, in my point of view, is an excellent decision of Europe already in the 90s. At local level, we can use public transport, we can use cars, we can use also cars at longer distances, but we have to keep an eye on the sustainability concept that we resumed before. Then the most flexible powertrains are the plug-in ones, but they are more expensive. We will speak about that next time. And nonetheless, sustainability is not an absolute concept because it depends on the characteristics of the territory. That's all. Sorry if I've run a bit, but I wanted to provide you a number of basic elements for the next seminar, and I hope to have satisfied your expectations. Thank you.